So I want to show you guys, I have some data now here over the last week and a half or so. Um, so we can look at this thing, learn a bit more details, useful, more useful information that this logger has captured. So I've been playing around with him, kind of zooming in on the data to take a look at it. But this is what happens when you press reset. It's not working. It should be resetting the chart, the Google chart, but it's not. That's interesting. Oh, it did reset it. Anyways, let me kind of zoom out on this thing. So this is like zoomed all the way out. You can see there's nothing useful here. You see some oscillation, but it's compressed too much. By the way, on the screen I'm watching some comedy, but as you zoom in on the data, you can see more useful information. It kind of unravels and gives you more insight into what's happening. So just to give you some background, this temperature sensor is in my basement where there's a heat source that turns on and off. So when it turns off, it slowly goes down. Temperature goes down to its lowest point, and the heat source turns on, goes up, and it kind of stays in this flat range, and it goes down up. Kind of, you can see the pattern repeat. Now here recently, it's been getting colder outside because it's towards the end of September. Today is September 28th. So you can see, since the temperatures outside are falling lower, it's affecting the inside temperatures in my basement. Obviously, it's going to affect your whole house. So recently, it's been falling down more than so. This endpoint was 61 point, about 62. The lowest point here is, about 62, 62. But this one is almost 60.5, so a degree and a half lower. So that's interesting. But you can keep zooming in on this data to see more in-depth pattern. So this, you can see this is a day's worth, right? September 26th to the 27th, and 27th to the 28th, and this is the latest. But you can just keep zooming in to see what's happening in more detail. So it's around 12:30 right now, right, noon. This sensor captures a data sample every minute, so it's still operating. Let's refresh this, see, get some more data in. It's loading. The more data it has, it takes a little bit longer to load, but you can see the latest sample is 12:16 or about. So let's keep zooming in. So again, around 7 o'clock, the heat source turns on. You can kind of see it spike, and then it kind of hits its maximum, and it keeps it flats. But there's also outside influence. There's the internal heat source that's influencing this, and then outside slowly, because it's the sun comes out. It's a little bit hotter outside, so this influences us towards the end. But it is a pretty neat thing. You can monitor this a lot of detail. So I just zoomed in. You can see the last. This is every 5 minutes. This is 5, so 15, 20, 25, 30. You can see the range of what's happening here. There's a little spike, second by second readout. You can kind of see what's happening, and you kind of see if there's any issues with the sensor itself. If there's any unusual spikes in the data reads that you shouldn't expect from especially if it's not happening in an environment. So you can zoom in, and you can also pan on the data. So let me zoom in further, and then you can kind of just pan, right? So you can go to the left, kind of inspect it, and you can keep zooming out. So pretty useful. The two features that I've added to this is the ability to clear your data. So let's say you're putting it whatever. You can use this for any application to measure temperature. And you've calibrated your environment and you want to start to capture clean data. So that's what this is for. You can clear your data so you're capturing clean data from that point on. And you can also download this data. So you can see September 20th to September 28th. So it's about a week plus 1 day already. Today's 29th, so it's about half a day, but it hasn't completed yet. That's why it's still showing the 28th. We can download this data. Just press the download button, and you can open it however you want. By default, text edit. So let's see. You can see, here's the data for this entire 8.5 days. So it's pretty useful. You can download it. You can do analysis with it. You can upload this data to whatever tool you want. I have R Studio here, so I can do some additional analysis on it beyond this plot if I wanted to. I mean, there's just two variables that this is capturing. It's the daytime and the temperature sample. So this Google plot's pretty much displaying this on the x-axis, showing you the daytime, and on the y-axis is showing you the temperature in Fahrenheit. Another thing that I've changed is by default the code that was open source released is Celsius. I find that since I'm in the US, I wanted Fahrenheit, but you can switch it in the code. Let's look at the code. Let's go to my website. Because the website has a link there. That's why I called it for now, the Arduino Mini ESP8266. And here's the link to the GitHub. So if you click on examples, this gentleman, I think his name is Peter, I don't remember. If you click on examples and then the data logger 8 temperature, this is the code that I've used, and I've edited and added additional features. But he's got other things in here. You could incorporate other examples into this if you need them, or just any other code, or obviously add your own additions. But looking at this data logger, this is the C code, the Arduino C code. You can see kind of what's happening here. And then let me show you where the temperature is actually being captured. So see if I can spot it pretty fast. Okay, here it is. This is it. Get temperature from sensor. Float. It's a float. So see where it says here get temp C? All you have to do is change get temp F, and we'll pull Fahrenheit out of the sensor. You can comment this line out and just replace it with with F over C, and this will give you the temperature conversion. And then of course in the Google chart in the other document, I changed the display here. Anyways, cheers.